Hello and welcome with another video. Today I thought that I must first convey you a few points about chirality and achirality. What is the difference between a chiral and an achiral molecule, or a chiral and an achiral object? So, I'm Professor Dr. Mchem from Dr.Mchem Institute of Chemistry, University of St. Jamshoro. And I'm here to give you a few ideas with colorful examples about chiral and achiral molecules. So, what is the difference between chiral and achiral molecules, right? Or chiral or achiral objects. So chiral molecules are simply non-superimposable on their mirror images. They are non-superimposable on mirror images, whether when they are repeated in any direction in space. Whereas chiral molecules are superimposable on its mirror image. There are many examples which I'm going to tell you. First of all, you should know what is the difference between chiral and achiral objects. And of course, chiral compounds, chiral molecules are asymmetric in nature. That is, the central carbon atom is attached to 4 different groups, which I have explained you in my previous lecture. So today I would like to show you a few examples, starting from a very common and a very interesting example of a hand. I have made these 2 beautiful hands for you people so that you can superimpose them, right? So if this is a mirror plane, let's put it here. If it's a mirror plane, what you are going to see when you are going to superimpose them? Let's superimpose them. This is the left hand and this is the reflection in the right, on the right side. This is the reflection, this is the left hand, right? And you can see its reflection as your right hand. So now we are going to superimpose them. Let's superimpose them and see what is happening. Are they superimposed? Are all the fingers being superimposed or not? No, they are not. You can see they are not, right? The thumbs are on the opposite sides, right? It's just like that. So, and this is the first example of a chiral object, the hands. See the beautiful hands and see how you're going to superimpose them. No, they can't be superimposed, right? You can see here, they are totally not at all coinciding. The thumbs are on the opposite sides. The index fingers are on the other opposite sides. So they fail to superimpose. Then we take an example of left foot and right foot. Right? The left foot and the right foot, and we put it here. Right? So you can see a left foot and a right foot. The left foot is there, and you can see its mirror image at the right side. Now let's superimpose them. No way. They can't be superimposed. So they are also achiral. Just see. You cannot So I was telling you about, let's superimpose the second example of a foot, right? A left foot with its right foot as its mirror image. Let's superimpose them. No way. They can't be superimposed. You can see here. No, right? All parts are not at all coinciding. So this is again a very interesting example of a chiral object. A chiral object, right? This is also an example of a chiral object. Okay, third example is an example of a nail. This is a nail. Okay, so this is a mirror plane. I'll draw the well, this is again a nail, right? And its mirror image. Now here, when you are going to superimpose it, definitely it's not going to coincide, because when you put this nail over the top of this nail, the direction of these springs over them, these things, they will be at the opposite side. So they are not at all superimposable. Whereas if you draw a nail, another nail, yes, now if you look at them, if you will superimpose them, they are going to be superimposed easily. They can be placed on one at the top of other, and they will simply superimpose easily. The other part, they will simply superimpose without any difficulty. So I hope you are getting my point. So a chiral object is not at all identical. It's not at all identical. This is one of the very important aspects. That is, it is super. What it refers to, that is, it is superimposable on its mirror image or with its mirror image. And I've shown you many examples of chiral compounds, right? So So I just explained you what are chiral objects. They are non-superimposable. So simply chirality is referring to or is said to be chiral if it's chiral if it exists in the two stereoisomeric forms. And those two forms are non-superimposable mirror images of each one another. This is the simplest definition. The example of that was butane to all or 2-butanol. 2-butanol, which I just yesterday explained it to you people. 2-butanol is an example, right? It's simply a chiral compound. It's a chiral compound, whereas ethanol, it is an achiral compound. Now we'll jump to the achiral ones, but first we should be over with our chiral compound. In the chiral compounds, as I mentioned you there, in which the carbon atoms is simply attached to 4 different groups. There are 4 different groups that are attached to the carbon atoms: a hydrogen, a hydroxyl, a methyl, and a carboxylic group, something like that. So it has all 4 different carbon atoms, and it is also called a stereogenic center or an asymmetric center. So if we talk about the achiral compounds, now the achiral compounds or achiral object is simply superimposable on its mirror image, which I've just written. I've already written, so there's no need to write again. So it's superimposable on its mirror image. Now there are many examples. For example, you can take the example of these 2 bottles, these 2 flasks, or these 2 beautiful bottles. Now if you have a mirror plane between them, right? If you have a mirror plane between them, you will see the left hand bottle, you will see its image on the right hand side, and if you superimpose them, they are just the same. They are superimposed. All parts coincide. They are simply superimposed easily. You can see, right? So this is an example, a perfect example of an achiral compound. Now I have the flasks, the 2 flasks. You can see these 2 flasks. Now this is the mirror plane, right? Now this is the first flask and this is its image. Now you can simply superimpose them easily. They can be superimposed like this. They can be superimposed. All parts coincide. So this is again a wonderful example of a achiral compound, achiral object. Okay, another example, spoons. These are again the achiral, again an achiral object. You can simply superimpose them easily. Yes, just look at them. Easily they are superimposed. Fine. Another example, fork. Just see how easily they can be superimposed. All parts coincide. Superimposed. Again an achiral example. A perfect achiral example. So these were, balls. Of course, the tennis balls, the throw balls, the net balls, the baseballs. They are also the wonderful examples of achiral compounds. They can be superimposed. They are over there. You can simply superimpose them like this. So these were all the examples of achiral compounds, which are superimposable on their mirror images, like flasks, like bottles. Even I can show you another very interesting example of an alphabet. Alphabet I. you can superimpose them easily. The alphabet I, it's achiral. So I was telling you, we can check the achirality in the alphabets also. So I just showed you the alphabet I. It was simply superimposable on its mirror image. It was easily, was placed on one at the top of the other, right? And they were coinciding. Whereas the alphabet E, let's draw E. What would be its image in the mirror? It would be like this. So when you are going to superimpose them, what it would be like? They would be like this. And this would be like this. So it's again, no way. It's not at all a chiral compound. It's an chiral compound. This is chiral. This is a chiral compound. You cannot superimpose them. You cannot superimpose alphabet E, right? Whereas you can superimpose alphabet I, right? We just superimposed I. So this was the example of achiral compound, achiral molecule or achiral object, whereas this alphabet E is an example of a chiral object. Chiral compounds, now if we talk about the chiral compounds, they are found widely in the nature or throughout the nature. They are easily available. For example, you can take the example of glucose molecule. It's a very important and essential sugar, and it provides energy. It's a source of energy, and of course it's a chiral molecule. Glucose is a chiral molecule. It's an enantiomer and it occurs naturally. Glucose, as everyone knows, that it is not at all fully utilized as a source of our food, right? So all type of sugars, or you can say proteins, and for example other acids like nucleic acids, they are all chiral, and they all occur naturally, and of course in one or more enantiomeric forms. Now there is a question, why or what causes chirality? What causes chirality? What causes chirality? So this is again a new topic which I'm going to discuss in my next video, and I will tell you that of course it lacks something. It lacks something. It lacks something. And what is that? Something is symmetry. SYMMETRY. It lacks symmetry. And it could be a symmetry of some objects, or for example any sort of a molecule. And I will now let you understand this new topic, that is symmetry, in my next video. I hope you like this video and you know now what is the main difference between a chiral and achiral objects, what is the main how you can identify them, how you can even identify the two different alphabets. Now you can, for your own practice sake, you can find objects at your home and see their mirror images, and then find out that whether they are chiral or achiral. This, as I've explained you many examples like these forks, spoons, and of course these forks and hands, right? These were so interesting. Everything was so interesting. I showed you everything so that you can have the good idea about the knowledge about everything, the bottles. So inshallah, hopefully see you next time again with this topic, that is symmetry. Thank you very much.